Welcome to the Planet of Maths channel. In today's video, we'll talk how to rationalize the denominator. It's about ensuring the result doesn't have any root in the denominator. It can be in the numerator, but it shouldn't be in the denominator. The first part includes easier examples, like these here. In the second part, we'll talk about some more difficult examples. Here, you'll need to know the special product formulas to tackle these examples. So we start. First, we copy such a fraction. Then we extend the fraction bar and must multiply both the numerator and the denominator by something to eliminate the root here below. In this case, we will multiply both the top and bottom by the square root of 3, which means the root from the denominator. We put it to both the numerator and the denominator. Up here, nothing special will happen. It will result in 5 square roots of 3, and at the bottom, 2 identical square roots when multiplied give the number under the root, so here it will be 3. And that's the result for this example. In example B, we proceed similarly. First, we rewrite our fraction. Extend the fraction line and add the square root we have in the denominator to both the numerator and the denominator. That is the square root of 5. Since it is here, we add it to the numerator. And in the denominator, nothing is happening in the numerator. 2 square roots of 5. And here at the bottom, this square root of 5 times this square root of 5 when multiplied give us the number 5. And in front, we still have this number 3, which was not involved here. You can take a moment to see if anything cancels out here. However, this 2 won't cancel out with anything, not with 3, nor with 5. Now we write down the result. In the denominator, 3 and 5 are multiplied, giving us 15, meaning 2 square roots of 5 over 15 have resulted here. Another example, 2 divided by the cube root of 4. Here we have the cube root, so it's probably a bit different, because here it's not enough to just add the cube root of 4, as we've been doing so far, because multiplying these 2 roots won't eliminate them. Here we need to add 2 of such roots, 2 on top in the numerator, and 2 at the bottom in the denominator. First the 2, here without any changes. 2 such roots can be multiplied by each other. 4 times 4 equals 16. And at the bottom, 3 identical cube roots. When multiplied by each other, they just turn into the number under the root. Here it will be 4. Well, the end of the example is not yet, because here we can still reduce the 2 and the 4. Here we get 2, and here we get 1. So ultimately, we get the cube root of 16 divided by 2. That's the result for this example. 2 more examples. Here we have a bit more of these elements. There's addition, so it'll definitely be more work. But we start as before. We rewrite our fraction, extend the fraction bar, and we will multiply by the square root of 2. At the bottom, the square root of 2. At the top, the same. But at this moment, it's not okay, because if there is addition here, I have to enclose this addition in parentheses. We can multiply. Let's start at the bottom. The square root of 2 times the square root of 2 gives us a result of 2. At the top, we need to multiply this root by the square root of 3. From this multiplication, we get the square root of 6. And the square root of 2 multiplied by 6 gives us 6 square roots of 2. And that's the result for this example. Here 6 and 2 cannot be simplified because there is addition, and this addition prevents simplification. Next example, we rewrite this fraction, extend the fraction line, and multiply both the numerator and denominator by the same square root, the same one that was at the bottom, which is by the square root of 5, here and here. And again, since there is addition in the numerator, we need to enclose that addition in parentheses. Multiply at the bottom. The square root of 5 times the square root of 5 equals 5. And at the top, we multiply the square root of 5 by the square root of 2, which gives us the square root of 10. There is a plus sign, and also this square root of 5 needs to be multiplied by the square root of 3, which will result in the square root of 15. And here, of course, nothing can be reduced any further. You can't reduce the number under the root with the denominator's number, and you can't reduce because there's addition here. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Maths channel.